Hi everybody. This is me going over the phase changes handout. Most of the people that I got to talk to today said they still had it. I know a couple people say that they left it at school, so I'm going to tell you what you have to write down on your own paper if you don't have this actual handout with you. Okay, you were supposed to have done this front page the week before we got out, so let's just go over it real quick. Melting is obviously going from what to what? A solid from a liquid. A solid to a liquid. And then freezing is obviously going to be liquid to a solid. Evaporation is going to be liquid to gas. Condensation is going to be gas to a liquid. Sublimation is going straight from a solid to a gas, and that is bypassing the liquid phase completely, just skipping liquid altogether. And deposition is going the opposite of that, so it's going to be going from a gas to a solid. So if you made any, simple careless mistakes or anything on this page, just go ahead and mark them out and fix them, okay? All right, now the next page, if you do not have this handout, these are the two things that you need to copy down on regular paper. Okay, you have to be able to do this and this. Okay, so let's get started, and you can just obviously pause the video to get a chance to copy them down. So the first one is going from solid to liquid, so just follow it around, and so obviously that's going to be melting. And number 2 is going from liquid to solid, so that's going to be freezing. Okay, number 3 is going from a solid to a gas, skipping liquid, so that's sublimation. Number 4 is going from a gas to a solid. The opposite of sublimation is deposition. And number 5 is going from a gas to a liquid, which is condensation. Number 5 is going from liquid to gas, and the only one left is evaporation. Okay, so again, you'll have to pause the video and copy that down if you don't have the handout. And let me know if you have any questions about that. So let's look at this. This is the main thing here that we need to start getting used to, this type of graph. So you see we've got temperature going up to the side and heat energy or thermal energy going from left to right. So we start out, A is going to be a solid. That's what we start out with, okay? And what you can't see on here is like a picture of a solid. And basically it's just showing you that the particles in a solid are extremely close together. And so then for a liquid, you're going to have them a little bit further apart, if that makes sense. And then when you get to a gas, they're going to be going in different directions and spread out. Okay, because they're bouncing off of each other. All right, so what do we fill in down here? Okay, we're talking about going, here's a solid. Now here is where it starts to actually do a phase change. Okay, the solid line here and the solid line here are the only times that it's actually doing a phase change. And notice what is not different. I mean, what is the same here, and that's the same temperature. So during phase change, temperature stays the same until the phase change is over. Okay. All right. So let's talk about number 7, because we finished with number 6 up here. So let's go with number 7. And if we're at a solid and this is going over here and it hits what? Follow it up, a gas. Okay. So we know that's going to be sublimation. Okay. Now right here, we're going from a solid to a liquid, or from a liquid to a solid. So we know that a solid to a liquid is melting, and going from a liquid to a solid is freezing it. And we were going to do this in the lab as soon as we came back, so I'm pretty disappointed we don't get to do that. Let's look up here at 10 and 11. So we're going from a liquid to a gas, and from a gas to a liquid. Okay, so liquid to gas is evaporation, and gas to a liquid is condensation. Okay, so I hope that graph makes sense. When we have our video conferencing, you can let me know whatever questions that you have on that. Okay, so if you turn to the next page, you have this lovely diagram, which basically has got the same shape as what we just did, right? So this graph was actually made from data from the lab. So this is what we would have done in the lab. Okay. All right. So we have to fill in all these blanks according to that. So at point A, the beginning of the observations, the substance exists in a solid state. Material in this phase has a definite volume and a definite shape. Okay, because this is at the very beginning, and we know down here it's a solid. Okay, so it has a definite volume and shape. With each passing minute, energy is added to the substance. This causes the molecules of the substance to vibrate more rapidly, which we detect by a steady rise in the substance. At point B, so here we are at point B, the temperature of the substance is what? Okay, so this is point B right here. So how do I find the temperature, which is on this axis? I just follow it straight over, and it's in between 60 and 80. So it has to be 70 degrees Celsius. Okay, so the solid begins to do what at that point? This is the solid. Okay, then it's going to have its phase change. So this is what? A liquid. We'll go ahead and finish here. It goes through a phase change to become a gas. Okay. All right, so here we are. The temperature of the substance is 70 degrees. The solid begins to melt. At point C, the substance is completely melted, or in a what state? If it's melted, it's going to be in a liquid state. Material in this phase has what kind of volume? At this point, if it's a liquid, it's going to have a definite volume. But does liquid have a definite shape? No, it does not. So we're going to write indefinite as the opposite. Okay. The energy put to the substance between minutes 5 and 9 was used to convert the substance from a blank to a blank. So go from the time of 5, which is right here, to 9, which is right here. So follow that up, right? Okay. And what do we put there? What's it going from? A solid to a liquid. Okay. Okay. This heat energy is called the latent heat of fusion, which is very important. So I need you to highlight that, and we're going to come back to that after we finish. Okay. All right, so let's look between 9 and 13 minutes. Okay, so we have 9 is right here, and then 13 is right here. Okay, so we're going from a what to a what? We're going from a liquid to a gas. So what is happening here between 9 and 13 minutes? The added energy increases the temperature of the substance. Because you see the line is going up the axis, and so the temperature is increasing as it goes. Okay. All right, so during the time from point D to point E, so here's D and here's E, the liquid is doing what? If you put liquid on the stove because you're going to make mac and cheese, which is what we do every day in my house, you know that when you start to boil, you start to get gas from that. So the liquid is boiling. By point E, the substance is completely in the blank phase. And what do we call that phase? We call it either a gas phase or a vapor phase. Okay? Material in this phase has an indefinite shape, just like I drew on the previous page where the molecules are moving around. Gas does not have a definite shape. So it's an indefinite volume and an indefinite shape. The energy put to the substance between minutes and 13 and 18 converted the substance from a blank to a blank. So 13 to 18, if you follow 13 and you follow 18, we went from a liquid to a gas. This heat energy is called the latent heat of vaporization, which is extremely important. So understand, liquid to a gas is called latent heat of vaporization. You got to know that. Beyond point E, the substance is still in the gas or vapor phase, but the molecules are moving very much rapidly, as indicated by the increase in the temperature. Okay, so it's making the molecules go crazy up here. Okay, they're a little bit more together here, and they're very much close together here. Okay, now let's look at the bottom part. It says, which of these 3 substances was likely used in this phase change experiment? So these made up substances, here's their melting point and here's their boiling point. Okay, so let's go up and look and see, and you will see that from 70 degrees to 140 degrees. Okay, 70 degrees to 140 degrees, it's going to be fusium. Okay, so take some time and look at that and figure out why it's not the rest of these. Okay, where does it start? it starts down at 20 degrees, right? So can I choose anything that starts at 40 degrees? No, because this started before 40 degrees. So that's why that one was out. And the top one is out because it doesn't stop at 100 degrees. If you look up here, you see 100 degrees right here. We've still got a whole lot to do, so that's why it can't be that one. Okay.